Hello and welcome. In this second video for Module 10, we're going to look at the solutions of examples 10.2 and 10.3. Both the Ti-84 and the Geogebra statistics applet from our course will be shown for their solutions. So example 10.2 says it is believed that the average grade on an English essay in a particular school system for females is higher than for males. A random sample of 31 females had a mean score of 82 with a standard deviation of 3, and a random sample of 25 males had a mean score of 76 with a standard deviation of 4. At a 10% level of significance, can it be concluded that females score higher than males on English essays? All right, so we're dealing with a hypothesis test again. The hypothesis, the two different hypotheses are either the null and the alternative. The null, again, is the assumption of equality. So for the null hypothesis, we would write something to the effect of, there is no difference on English essays between female and male students. In symbols, we could say that the mean for one population is equal to the mean for the other population. Or if we were to talk about the subtraction, again in math, the difference is when we subtract. If we subtract these two means, we would get 0 because there's no difference. They are the same values. The alternative hypothesis is that, well, the average grade on English essays in a particular school system for females is higher than for males. So we would say something to the effect of female students earn a higher grade on English essays than male students do. So we are going to assume here, the way that I have it written, that the population 1 is the female students. There's nothing that says we have to do it this way. Just you have to choose in one way or the other. So the first population is greater than the second population. So population 2 must be the male students. So the female students score higher than the male students. Or if we were to subtract these two, their difference would be positive, again, meaning that female students score higher than male students. One of the challenges with hypothesis tests for two samples is that there's so much information in the word problems that it can get a little bit tricky as to what it is that we're trying to use. So I'm going to go through here and underline all of the information for females, and then I'll do the males in a separate color, and we'll write these into like a little table. That usually helps to organize it. So the sample size for the females is 31. Their mean, x bar, was 82, and their standard deviation, s, was 3. And the males were a sample size of 25, had a mean score of 76, and a standard deviation of 4. One thing I kind of glossed over is that since we are talking about a random sample with these sentences, the standard deviations of these sentences are referring to the sample. So these are sample standard deviations. So we're using the sample standard deviation symbol, and we're going to be using the t-distribution because of that, which is the next thing to discuss, the t-distribution. Why? Because the sample standard deviation is given for both. All right, from here, we're going to take our null and alternative hypotheses and determine the rejection region. The rejection region will be the critical values or the critical region of the graph, where if our sample data lies within it, that means that we have enough evidence to reject the null hypothesis. So reject H sub 0. And the decision rule, again, describes the picture or describes the shaded region. So we're going to reject the null at alpha equals 10% if the t-score of the sample statistic is bigger than whatever this t-critical value is. This t-critical value is going to come from either inverse t or the t-distribution. And the way that we will do this is in the Ti-84, we will select second vars to pull up the distribution window and then select number 4, inverse t. The area we are looking for is the top 10% of the graph. So 10% written as a decimal is 0.1. We know that the sample size of the females is 31, the sample size of the males is 25, and the degrees of freedom formula is n1 plus n2 minus 2. So we could actually do that calculation. 31 plus 25 is 56, minus 2 is 54, or we could just leave it in there in this equation form. And we'll get negative 1.297 or negative 1.30. Now I could have technically written in here 0.9 because this is a right-tailed test, but since the t-distribution is symmetric, it doesn't really matter. We could just make this 1.30. So we are going to reject the null hypothesis if our t-score is greater than 1.30, or we will reject the null hypothesis if the p-value, the probability value of the sample statistic, is less than 10% or less than 0.1. Just want to take a second to show how to find the critical t-score for the GeoGebra folks. In the probability calculator, we're going to select the student distribution from the drop-down window, make this a right-tailed test. The degrees of freedom is the same calculation as before, and then we're going to put in 0.1 for our area, and this will be our t-critical value. Okay, from here, we need to take the data from the question, the sample data, and type it into our calculators. So give me a second. Let me just copy this, copy, and then over here we'll paste it. I'm also going to paste it over here just so I have it when we do this part of the video too. All right, so we are going to have to use the two-sample t-test because we are doing a t-distribution test for two different samples. Really quickly, to get to that, let me change the color, we would select stat, and then use the right arrow twice to bring up tests, and then go down to number 4. Just make sure everything's on the screen. Okay, cool. So from here, we're going to select stats because we're given the information. If I gave you a list of raw data, we could choose data and then type them into L1 and L2, but we're not. We're just going to take all of this information here for the females and type it in. Take all of this information here for the males and type it in for the second population. We'll choose that the population 1 is greater than population 2. And then we just need to confirm that the standard errors should be pooled. Again, to do the pooled test, we need to do or check is S1 divided by S2 less than 2. And we're generally going to put the larger standard deviation on top anyway. So for this one, it doesn't really matter which is 1 and which is 2. I'm going to put the larger one on top. Is 4 over 3 less than 2? Yes, it is. So therefore, this is going to be a pooled standard error. So just select yes for standard error to be pooled. And we'll get a t-score of 6.41 and a p-value of 1.83. And a p probability should always be less than 1 because this is the scientific notation. So this should be 0.000000018. So a very, very, very small probability that this would actually occur. Let me show how to do this in GeoGebra real quick, and then we will talk about the conclusion. So again, in the statistics applet, we're going to use the drop-down arrow and select t-test difference of means, because we're comparing two different means. And then we're just going to go through and type in all the same stuff we did before. The null hypothesis is that there is no difference. We're going to choose a right-tailed test. Again, we're going to choose pooled, as we just talked about. Type in all the information from the first sample, type in all the information from the second sample, and we will get the t-score and the p-value. Same one that we had from the TI calculator. So we write in the t-score is 6.41, which means that if this is 3, 4, 5, 6, our sample information will be like way over here on the graph, basically non-existent. And the p-value is essentially 0. Therefore, there is sufficient evidence to reject the null hypothesis at alpha equals 10%. Remember, the null hypothesis was that they were equal. So if we're saying that that it's not true that they're equal, therefore it must be that female students do earn a higher average than male students do on this English essay. All right, now we have example 10.3. Example 10.3 says, a powder diet is tested on 49 people and a liquid diet is tested on 36 different people. Of interest is whether the liquid diet yields a higher mean weight loss than the powder diet. The powder diet group had a mean weight loss of 42 pounds with a standard deviation of 12 pounds. The liquid diet group had a mean weight loss of 45 pounds with a standard deviation of 14 pounds. Test the claim at a alpha equals 1% level of significance. So again, the null hypothesis is the assumption of equality. Therefore, there would be no difference in weight loss for the liquid or the powder diet. Mu1 equals mu2, or the difference between them is 0. The alternative is of interest is whether the liquid diet yields a higher mean weight than the powder diet. So if we do this way, mean of the first population is greater than mean of the second population. Yeah, I think this should be the other way around. So this is an example of how challenging these hypothesis tests can be in that we're comparing two different populations. If we did this, then that would mean that the liquid is population 1, the liquid diet, and the powder diet is population 2. But I think the rest of this solution that I've already created is based off of, the other way around. So all of this has to change. Okay, I apologize for that. So there's nothing wrong with the sentence here. The mean weight loss for the powder diet is less than the liquid diet. That's totally fine. But just to keep it in the same order as the hypothesis test question here, they give us all of the powder diet information first and the liquid diet group second. So we're just going to use that here. We're going to say population 1 is the powdered diet, and then population 2 will be the liquid diet. So let me just change this real quick. Basically, all that we're going to do here is just change this from a greater than test to a less than test. Mu1 is less than mu2. Actually, give me a second. So I just used some, I guess, electronic whiteout. And now we can change this to a less than claim. And the only reason we're doing that is because, oh, what happened there? Is because we're changing the way that I have the populations written. The powder diet is less than the liquid diet, so therefore we can just write that mu1 is less than mu2. Is this a normal distribution or a t-distribution? Well, again, most of these, if not all of these, will be t-distributions because in the real world we'll only have sample information, sample data, so the sample standard deviation will be given. From here, I'm going to write down all the information for the powder diet. we know that there was 49 people in the powder diet group, so N equals 49. And they had a mean weight loss of 42 pounds and a standard deviation of 12 pounds. And for the liquid diet, there was a sample size of 36, a mean of 45 pounds, and a standard deviation of 14 pounds. I can tell already that this is not greater than 2 difference, so this will be pooled. 12 and 14 are close. 14 divided by 12 is not more than 2, so this will be pooled. Now that we've changed the alternative hypothesis to be correct and be less than, we will shade the rejection region way over here. Reject the null hypothesis at the alpha equals 1% level. So therefore we will, reject the null hypothesis at alpha equals 1% if the p-value of the sample statistic is less than 0.01. And again, we just need to figure out what the t-critical value is. The t-critical value comes from the inverse t function. We've done this in a couple of videos now, so it should be pretty quick. Second, vars, pull up the distribution window, select inverse t. Our area will be 0.01. And then we would just find the degrees of freedom, which is n1 plus n2 minus 2. And that'll give us a t-score of negative 2.37. Again, in GeoGebra, we would choose the student's distribution, choose it to be less than, type in the area of the rejection region, 0.01, and this will be our t-critical with the degrees of freedom of 83. Again, 49 plus 36 minus 2. So we will reject the null hypothesis at alpha equals 1% if the t-score of the sample statistic is less than negative 2.37. So we just need to grab our calculators, type in all the information, and figure out what our t-score is. So we can use that table from earlier. Hopefully you've been following along and writing this down on your own. This would be the powder diet. This would be the liquid diet. We want it to be less than, we want it to be pooled, as we talked about before. We'll get a t-score of negative 1.06 and a p-value of 0.1459, rounding. And in GeoGebra, again, we're going to have to use that applet, select the t-test difference of means, select that it is less than now, not greater than, ignore that. Again, it's pooled, type in the powdered information here, the liquid information here, and run the test. And you'll see that we get the same t-value even if we chose the wrong direction for the alternative hypothesis. The difference here is that I would get 1 minus the p-value if I chose the wrong direction. So before we said it was 0.1459. So if I do 0.1459, we would actually get 1.000 because it's just the complement, as we had talked about previously. If I had chosen the correct alternative hypothesis, we would get the same exact p-value. So I apologize for that, but hopefully this is making sense at this point in the semester. I'm really hoping that it is. So our t-score of negative 1.06 should be somewhere around here. Here's negative 1, so our t-value of negative 1.06 lies in the fail to reject region. So if it's in the fail to reject region, that means that we do not have sufficient evidence to reject the null hypothesis at alpha equals 1%. This means that the sample data does not show that the liquid diet has a higher level of weight loss than the powder diet, as was claimed. As always, if you have any questions, feel free to reach out. Otherwise, I hope you enjoyed the video, and I'll talk to you soon.